unit operation. So based on this journal, there's three different methods of pre-treatment of oil palm, empty fruit bunch for further production, which are aqueous ammonia (SAA), steam explosion (SE), and the ammonia fiber expansion (AFEX). This simulation is conducted using the SuperPro Designer version 9.5 software. So, for SAA method, there are 17 units of operation, while steam explosion had the least unit operation. Used are 16 units of operation, and for ammonia fiber explosion are the most unit of operation, which are 19 units operation. The difference between these three methods, which are SE method, use the clarification unit of operation, while the SAA and the AFEX use the ammonia evaporation unit operation, since both of it were using the ammonia for pre-treatment.
Hi everyone, so I'm Shahira Wajiha. So today I will explain about the operating condition. First type of retreatment are soaking in aqueous ammonia SAA, which is SAA pretreatment is chosen because of its simple process and high selectivity to maintain hemicellulose and eliminate lignin. This method is by soaking OPEFB in ammonia liquid 50%. The temperature is 70 Celsius and the time taken is 14 hours. Second, steam explosion (SE). The steam power has the potential to degrade the complex structure of lignocellulosic biomass. The steam pretreatment are 140 Celsius to 260 Celsius. Dry or PEFB was exploded in the reactor under saturated steam conditions at a temperature of 140 Celsius. The pressure is 2.8 bar. The retention time is 15 minutes. Third, ammonia fiber expansion AFEX, which is the ammonia best pretreatment process that has shown tremendous promise to cost-effectively reduce the recalcitrance of lignocellulosic biomass, xanthemically catalyze deconstruction into fermentable sugars. FX pretreatment use about 1 kg of anhydrous ammonia per kg of biomass at moderate temperature 90 Celsius to 100 Celsius. High pressure 250 psi to 300 psi. The time taken in releasing the pressure resulting in biomass disruption are 30 minutes. Anhydrous liquid ammonia was added to PEFB in the ratio 2:1 dry-wet basis, and the residence time was 30 minutes at 102 Celsius and 325 psi. That's all from me. Thank you.
In the salt in aqueous ammonia pretreatment method, the input consists of the all plum empty batches, OPEFB, and an aqueous ammonia solution. OPEFB is soaked in the ammonia solution, allowing selective removal of lignin. As a result, the output includes pre-treatment OPEFB, which increases cellulose and hemicellulose content, as well as a separate lignin stream that will be selectively removed from the biomass during pre-treatment process. Then a process treatment method involves input of OPEFB and saturate stream. OPEFB is subjective to high pressure and high temperature stream condition. This stream explosion process produce pre-treatment OPEFB with hydrated petally hydroxide hemicellulose modified imine, increases surface area and describe solution cyclically and degree of polymerization. In addition, the system emits stream and depend of system design of gas treatment. They may to various organic compound in the emitted stream. The ammonia fiber expansion pre-treatment method requires OPEFB and anhydrous liquid ammonia as input. The OPEFB is loaded into high-pressure stainless steel reactor and the reactor lid is closed. Anhydrous liquid ammonia is then added on the OPEF, allowing pretreatment under certain conditions. The output stream include OPEFB treatment with modified cellulose and lignin fraction. During the pressure release step, the system releases pressure and ammonia gas as byproduct.
Next, move to simulation flowsheet of furfural production using steam explosion pre-treatment of OPEFB. For this method, it starts from shredding, bulk flow washing, sun drying, grinding, mixing, pre-treatment, cooling, clarification, washing bulk flow which is P10, mixing, hydrolysis, condensation, cooling, decanting, and the final is 2 of distillation. This is a simulation flowsheet of furfural production using soaking in aqueous ammonia pretreatment of OPEFB. For this method, it starts from shredding, bulk flow washing, sun drying, grinding, mixing, pretreatment, decanting, ammonia evaporation, condensation. The decanting also go to washing bulk flow 2, which is P10, mixing, hydrolysis, condensation, decanting, cooling, and 2 of distillation. And the last method is a simulation flowsheet of furfural production using ammonia fiber expansion pre-treatment of OPEFB. This treatment is more economically. In this treatment be same with SAA and SE method but more complete. This method start with shredding, washing bulk flow, sun drying, grinding, mixing, pre-treatment, cooling, decanting, ammonia evaporation, and condensation. The decanting also go to washing bulk flow 2, which is P10, mixing, hydrolysis, condensation, cooling, decanting, and 2 of distillation.
Next, for the operational analysis, we do the system boundaries for all 3 methods. The first system boundary is the soaking in aqueous ammonia SAA system. The second boundary is the steam explosion pre-treatment SE, and the last one is the ammonia fiber expansion effect boundary system. All these boundary systems involves processes such as shredding, washing, sun drying, grinding, mixing, pre-treatment, decanting, ammonia evaporation, condensation, hydrolysis, cooling, and distillation. The majority of inputs for these 3 systems include oil palm empty fruit bunches OPEF, water, air, ammonium hydroxide, and sulfuric acid. As for the outputs, they mainly consist of wastewater, air emissions, water vapor, furfural, levulinic acid, and sulfuric acid. Thank you.
Hi, hello, good day. My name is Shara Shalin Sim and my metrics number is J280734. Today we'll be talking about the technical economical analysis of furfural production with various pre-treatment of oil, palm, and pea fruit bunches using Super Pro Designer. My part will be the equipment Gantt chart, which involves 3 pre-treatment methods, which is the first one is SAA, stands for soaking in aqueous ammonia. The second one is steam explosion, stands for SE. And the third one will be FX pre-treatment, which stands for ammonia fiber expansion. Among all these 3 pre-treatment methods, the most economical one will be the FX pre-treatment method because it only involves in 8 equipment process, which is the first one is the shredding, followed by washing, sun drying, grinding, mixing, pre-treatment, decanting, and also the last one is ammonia evaporation. That's all for me.
The success of every company depends on the effective use of the labor. To maximize efficiency, cut expenses, and meet organizational goals, it entails strategically distributing and controlling the personnel. Company may guarantee that labor resources are used in the most effective and efficient way by properly planning and scheduling the job. This until delegating activity in according the employee expensive workload and experience in addition to putting in place productions and technological environment that improve workflow. Addition, spend money on staff, training and development may improve their ability and raise productivity as a whole. Company may increase productivity, cut waste, and ultimate spin corporate expansion and profitability by properly controlling their use of labor.
For the pretreatment technology analysis, we can say that FES pretreatment gives the highest hemicellulose recovery, so it also gives the highest production yield, which is 14.8%, compared with SAA and also SE, which give a yield of 12.5% and also 12.8%. However, FES pretreatment requires more solvents and SAA pretreatment because it uses anhydrous ammonia. Meanwhile, SE pretreatment gives the lowest number of units because there is no ammonia recycling process. SE pretreatment also gives the highest utilities needed and waste production. And moreover, from this table, we can see that there is a summary of the pretreatment methods, and according to different aspects includes solvent, utilities, and also waste. And when we come to the economic analysis, there are two types of costs, which is total capital investment, TCI, and also operational expenditure, OPEX. TCI is the sum of all fixed capital costs and the working capital costs calculated, and the table summary the cost needed for TCI. And we can see from the table, SAA used the most cost for the TCI process. Meanwhile, OPEX is a cost incurred by a company to carry out production and other supporting activities, such in the year. OPEX components are raw materials, oil palm anti-fumigant, ammonia, sulfuric acid, water, labor, auxiliary facilities, laboratory, waste treatment, and also utilities. OPEX value obtained annually for SAA pretreatments is dominated by raw material costs. Meanwhile, OPEX values of SE pretreatment is dominated by utility costs, and OPEX value of a FES pretreatment is dominated by raw material costs. And the three variations of pretreatment for fulfilled production from oil palm anti-fumigant can be considered economically feasible from the profitability parameter values. This can be seen from the value of net present value, NPV, which is greater than 0, and the value of internal rate of return, IRR, is greater than weighted average cost capital, WACC, which is equal to 9.6. Meanwhile, fulfilled production from oil palm anti-fumigant with a FES pretreatment is more economically than fulfilled production with SAA or SE pretreatment. This can be seen clearly from the better value of a FES pretreatments, profitability parameters with greater ROI, NPV, and IRR values, and shorter payback periods. In conclusion, this study shows that fulfilled production with a FES pretreatment is more economically feasible than with SAA and also SE pretreatment by the value of profitability parameters as follows. Internal rate of return, IRR, equal to 49.77%, net present value, NPV, at 183 million and payback time equal to 1.7 years. This study also found that the most sensitive parameters that affect the NPV, IRR, and also payback time significantly is production capacity. Thank you for listening.